Okay, so here's the practice test that I gave you, and we'll go through the answers and see if I can't help some stuff make sense. And so here's the first question. We have a ruler, and we've learned in this class that every time you see a linear scale, or which is a line with equal space markings on it, your first task is to figure out what the spacing of the lines are. So if this right here is the tens place, that means this right here must be the ones place. Which means this scale, no matter what, will be plus or minus, let's see, the ones place, the next place down is the tenths place, and these are centimeters. So no matter what I measure with this scale, it's going to be plus or minus 0.1 centimeters. So as I look at this first line, I'd say that's about 8, but it's a little bit past. So I'll say that's about 8.1 centimeters, plus or minus that 0.1 centimeters, because that's the uncertainty, and the instructions say I need the uncertainty also. I also need the number of significant figures for each. Well, I measured the ones place, and I measured the tenths place. The guess counts as a measured place. So that'd be 2 sig figs. Okay. This other arrow, let's see, 50, 51, 52, 53, 54, 55, 56, 57, a little bit past 58. So I'll say that's about 58.1 centimeters, plus or minus that 0.1 centimeters for the uncertainty. But now, because I've made it further along the ruler, I have a tens place, a ones place, and a tenths place, so that'd be 3 sig figs. Okay, next ruler. Okay, let's do that same thing. What's the smallest line worth? Well, these major ticks, or major lines, are the tenths place. That makes these the hundredths place, which means everything on this ruler needs to have a plus or minus 1 more than the hundredths place, which would be the thousandths place, and those are centimeters. So the uncertainty is determined by the ruler itself. This one, boy, that's pretty close to 0. I'm not sure I could call it 0, so well, maybe it is 0. That's a weird number. I'm going to pretend it's a teeny bit past, just so that I'm not putting 0 down for my answer. I'll say that's 0.00 and 1 centimeters, but boy, I could be off by 0.001 centimeters. Oops, too many zeros. Because that's pretty close to the edge of the ruler. So how many sig figs is that? Well, these zeros don't count because I haven't got to that part of the ruler, so I'd say 1 sig fig. This one looks like it's right on the 0.5. So I'll put 0.500 centimeters, because no matter what, if this ruler is plus or minus 0.001, I must have a digit written in the tenths, hundredths, thousandths place, even if that number is 0. I'll say that could be off by 1 in that decimal place. I do not need an underline or anything there, because for 2 reasons. One, that 0 would not be there if it wasn't measured. Plus, there's no confusion or ambiguity because I have the uncertainty listed. This would have a measured place, a measured place, and a measured place. That 0 is just to see the decimal point better. So that'd be 3 sig figs. Now let's look at these. How many sig figs in each? Well, as I said up there, you wouldn't have these zeros unless they counted, which is unlike a math class because they wouldn't have put those zeros. So I measured the tens, ones, tenths, hundreds, thousands, so that's 5 sig figs. This one is similar to that one, in which case I haven't moved to that part of the ruler yet, so those zeros don't count. They're just decimal placeholders, and that's the only place that counts, so that'd be 1 sig fig. 12 hours, it feels like a whole number, but hours aren't things you can pick up and hold, so that has to be a measurement. That 2, I have to assume, the way it's written, could be off by 1. So I'm going to say that could be plus or minus 1, which makes this thing 1, 2 sig figs. 12 people is way different than 12 hours, though. 12 hours means I looked at a clock, and I think it must have only had an hour hand on it or something, or even a 10-hour hand on it, because I'm guessing the 1 hour place. Could be off by an hour. But if you're measuring people, you're not weighing them or measuring their height. You're actually counting them. So this is considered a counting number. And counting numbers don't have error because you're counting them, especially if you're counting relatively large things and a small pile of them. Now, if I was counting 8 million people, okay, maybe I could assume I'm off in my counting. But if I'm counting 12 people, I'm going to assume that means I have 12.0 and 000. It goes on forever. There's no error there. I know that's exactly 12. So in this class, we'll say either that's exact, instead of trying to say the number of significant figures. Or you could say it has infinity significant figures, because those zeros would go on forever. We haven't done a lot with scientific notation yet. That's 10 to the minus 5, so that'd be 0.1234211 if I wrote it out always, the long ways, or in standard notation. So these zeros don't count because they're placeholders, and I would have 1, 2, 3 significant figures. When things are in scientific notation, we'll learn that however many digits are up there, that's the number of significant figures. This is probably the most difficult one, because I can't tell by looking at the way it's written if that's plus or minus 1, plus or minus 10, or plus or minus 100. If they gave me more information, if they said plus or minus 1, then I would say, oh, 1, 2, 3, 4 sig figs. If they said plus or minus 10, I could say, oh, that 0 was the last one, 3 sig figs. But they didn't tell me that. So I'm going to write not enough info. Or better would be it's ambiguous, because I cannot tell the number of significant figures with the digits provided. How about this one? Well, those are placeholders, but that one's not. That 0 must be there for a reason, so I'm going to assume that that's 1, 2, 3 sig figs. Likewise with this, that would be 1 sig fig. Okay, so how do you do the calculator problems? Well, you have to recognize these are division problems, or multiplication and division problems. So the number of sig figs determines the answer, as opposed to the adding problems. So that has 1 sig fig, that has 4 sig figs. So I'm going to round this answer I get to 1 sig fig. So 21 divided by 0.03 comes out 700 on my calculator. Now, there's a problem with that 700. I know the units are going to be centimeters per second, but there's a problem with the 700. Just like up here, where I could not tell the number of significant figures based on that what's given, I can't tell if I just write 700 and put a box around it how many significant figures you're saying that's supposed to be. It's supposed to be 1. So in this class, we're saying in this special case only, because there's not enough info, I'm going to add some extra info, and I could put an underline under the 7 saying that's 1 sig fig. I could have done this also, 700 centimeters per second plus or minus 100 centimeters per second, which is more writing. Or we'll learn later, I could write 7 times 10 to the second centimeters per second, because when you put it in scientific notation, there's only one digit that shows. Okay, let's look at this next one. That's 4 sig figs, 3 sig figs, and those don't count, so 1, 2, 3, 4, 5 sig figs. 3 is the smallest number, so you get 54 times 4 divided by 0.002349, and you get a large number, 91954.022, and some more digits. Now the units will be centimeters times centimeters in the numerator and seconds in the denominator, but this has way more significant figures than the data. In fact, this piece of data right here only has 3 sig figs, so I have to round off right here. So that 5 will make that go up to 1, to a 10, which actually will carry over. And I'll get 92000. I won't put any decimal places because they're not going to be significant. Centimeters squared per second. But now look, I have the same problem I had here. I don't know which of these is the last digit that counts. Now up here I could tell I wanted to round off there. So I'm going to say that 0 is the 3rd sig fig, and that's the last place that counts. Once again, I could put plus or minus 100, or I could put 9.20 times 10 to the 4th. But at this stage in our class, I think putting an underline is the easiest way to go. This last problem. Do not stop and write an answer for the numerator and then an answer for the denominator and then divide, because that means you've rounded off twice. If it's all multiplication division, you should only round off once. So I have 0.0029 times 0.339 divided by 9.022, and then once again that's in the denominator, so I'll go another divided by 543.09, and that equals, my calculator says 2.0064 times 10 to the minus 7th. It actually says e minus 7, but that means times 10 to the minus 7th. Okay, so where should that be rounded off? Well, if I wrote it out standard notation, that has to move that way 7 spots. So that'd be 1, 2, 3, 4, 5, 6, and then the 2, 0, 0, 6, 4. That'd be the number in standard notation. I said that's 2 sig figs for the answer, so those don't count. I'm going to round off right there, which means I just wouldn't have put these numbers. So you get 0.02345, and the units would be, oh, and then plus that less 0, and the units would be, that seconds will cancel that seconds, so I get centimeters per Newton. Now, scientific notation would be easier, because that'd be 2.0 times 10 to the minus 7th. So sometimes scientific notation just makes showing the significant figures easier.